Good morning. Good morning, students. Okay. All of you have practiced whatever has been taught. Hmm? Okay, fine. So we are in the last part related to basic concepts of chemistry. Fine. So we are in the last part with related to this particular topic. Okay. So good morning. Good morning to everyone. Fine. So mole percentage and mole fraction calculation. Okay. So we did that one, right? So mole percentage and mole fraction. So we have done. Yes, in the last class we have done. That is with respect to mole percentage, that is mass percentage. Right? Mass percentage is nothing but mass of that element in which we are interested divided by total mass multiplied by 100. So that's where we have the formula. Mass percentage of any element, it will be mass of the element in which we are interested divided by total mass multiplied by 100, because it is a percentage. It's a percentage. Fine. So then, as you people have told, we have discussed about mole fraction. So what do you mean by mole fraction? Mole fraction is equal to number of moles of a element, in which we are interested or for which we are calculating, then total number of moles, So what do you mean by total number of moles? Total number of moles means where we have to consider solute and solvent. Okay? I think yes, Ullas, absolutely correct. Even we have discussed about molarity. So can you solve this question? Calculate the mass of sodium acetate required to make 500. Okay, very good. So molar mass required to make 500 ml 0.375 molar aqueous solution. Given molar mass. Okay, fine. We can calculate it. Okay, Manjunath. So that is with respect to molarity. Okay. So that is with respect to molarity. Now when I am talking about molarity, that is nothing but number of moles of a solute divided by mass of solution, volume of solution. Okay. So sodium acetate. So sodium acetate means CH3COONA. So this is nothing but sodium acetate. Anyway, we don't want this structure. Required to make 500 ml. Okay, 0.375 molar of 500 ml. Right? So anyway, if they would have not given the molar mass, then would have required. Now they have given the mass. Otherwise, it would be required the formula. Okay, 82.025. 82.025. Okay, 025 grams per mole. Okay, fine. So that's where we have the molar mass. Okay. Now we have to prepare sodium acetate of molarity 0.375 molar of 500 ml. Fine. Now we can assume. So for 1 molar, how much we require? What is the mass? For 1 liter, we will assume. For 1 liter, that means 1000 ml of sodium acetate, if I want to prepare, observe it carefully, I want to prepare 1 liter of sodium acetate of 1 molar. In that case, what is the mass I require? I require this one. What I will do is 82.025 grams. I will put it in 1000 ml. That is nothing but 1 liter. That will give the 1 molar. All of you will agree? Okay. So if I take 82.025 grams of sodium acetate, that is the molar mass. If I am taking 82.025 grams of sodium acetate, that means I am taking 1 mole of sodium acetate. Okay. So 1 mole of sodium acetate, if I put it in 1000 ml or 1 liter. Why I am taking 1000 ml? Because here it is 500 ml. So it will become 1 molar. All of you will agree? So it will become 1 molar. Now we will see, if I want to have, for time being, I will go with 1000 ml only. If I want to have 1000 ml, okay, so 1000 ml of 0.375 molar. 1000 ml of 0.375 molar. How much is required? That will be the question. How much is the requirement? So for 1 molar it is 82.025 grams. For 0.375 molar, how much it is? Volume is same. So 1000 ml. Try to understand. It's a good question. For your competitive exams, it may help you out. Got my point? So for 1 molar, it is 82.025 grams of sodium acetate I should take. How much I should take for 0.375 molar? So for 1 molar, it is 82.025 grams of sodium acetate. Okay. So how much for 0.375 molar? Okay. So that means molar will get cancelled. Whatever answer will come, it will be in grams of sodium acetate. Can any one of you tell me the answer? So 82.025 grams multiplied by 0.375. How much? Any one of you have got the answer? Got my point? Yes, Gauri, it is number of moles by volume. Now the question here is, for 1 molar it is 82.025 grams of sodium acetate we should take. How much we should take it if I want to prepare 0.375 molar? Okay? Okay, 30.75. Very good. So that will be 30.75. Now, observe it carefully. That is not the final answer. 30.75 grams of sodium acetate. If I put it in 1 liter of water, I will get 0.375 molar. But that is not the answer. Final volume they have asked for 500 ml. Right? So final volume is meant for 500 ml. So simply you can divide it by 2. No doubt. Because 500 is the half of 1000. So half of this one we can do. Right? So 30.75 divided by 2. Or we can tell that for 1000 ml. For 1000 ml, it is 3075 grams. Right? For 500 ml, how much it will be? Right? So, what will be the final answer? It will be 15.37, no doubt. Okay? So, for 1000 ml, it is 30.75 grams of sodium acetate. For 500 ml, how much? But the final molarity will remain same. Final molarity will remain same. All of you have understood? Very good. So it will be 15.37 grams. So once again I will explain. You want me to explain or you have understood? So the question was, we have got sodium acetate, chemical they have told, and it will be, they have made it easy by giving the molar mass also. It is 82.025 grams per mole. That is the molar mass of sodium acetate. If they would have not given the molar mass, by using the formula you should have calculated, but they have reduced your burden by giving the molar mass. Now the required concentration is 0.375 molar. Required volume is 500 ml. So we can directly calculate for 500 ml, no doubt. But instead of that, I am using two steps. So first one, for 1 molar, I require, this is the mass of sodium acetate. For 0.375 molar, how much I will be requiring? So by that, I have seen that it will be 30.75 grams of sodium acetate. That means for 1 molar, this many grams. For 0.375 molar, how many grams? So whatever answer I have got, that is meant for the 1000 ml. So now, for 1000 ml, it is these many grams of sodium acetate. How much for 500 ml? So ml will get cancelled. The answer will be 15.37 grams of sodium acetate. If I put it in 500 ml of water, I have got the required value or required concentration. Done? All of you have understood? Manjunath, you have understood? This was the question from you, right? Oh, so many answers are there. Okay. Yes, Manjunath. Understood? All of you? Any doubt in that? Okay. So in that case, we will solve another pattern in molarity. They may ask in your competitive exam, we will solve another pattern of question from molarity only. Okay? Another pattern of question from molarity, we will solve it. Okay? This one we have done. Okay. Fine. So all of you can write it down. We have, this is related to molarity only. So we have 1 molar solution of glucose. We have 1 molar solution of glucose. Prepare 0.2 molar of 200 ml solution from it. Okay? So once again I will repeat. It is related to molarity only. We have 1 molar solution of glucose. So prepare 0.2 molar of 200 ml solution from it. So these type of problems might be there in your competitive exams, and along with that, when you go for higher studies, so this type of solution always you will be preparing. Always. It's a very common process. When you go for higher studies, in the laboratory, in the practicals and all, you will be doing this one. Okay? Fine. So one thing, first one I will solve it. Now what we have is, given data is, now I am talking about the answer. So what we have the given data? Given data is 1 molar solution of glucose. 1 molar solution of glucose. Then what is next? What we require or what we have to prepare? What we have to prepare? So that is 0.2 molar. 0.2 molar of 200 ml glucose solution. Right? All of you have understood? So that's what the given data is 1 molar solution of glucose. What we have to prepare is 0.2 molar of 200 ml solution of same glucose, or from this we have to prepare. So that means, observe it carefully. So this one I will call it as a stock solution. This one I will call it as a stock solution. Stock solution means already I have this solution in my hand. Already they are present in my laboratory. So which is that one? 1 molar glucose solution. So by using that solution, I have to prepare 0.2 molar of glucose solution of 200 ml. Fine? All of you have understood? So for this, we have to use one formula. So that is M1V1 is equal to M2V2. So why I am discussing this problem? Because this type of problem you will come across in titration in your laboratory, not even to go for higher studies. In your first PU and second PUC practical titration will be there, one titration. So there you will be using this formula M1V1 is equal to M2V2, where M1, M2 they are nothing but molarity, two different molarity. So what is M1 and M2? They are nothing but molarity, two different molarity. What is V1 and V2? They are two different volumes. They are two different volumes. Got my point? So that means I have 1 molar of glucose solution. I know one of the molarity, that is 1 molar. I have to prepare 0.2 molar, that means I know another molarity also. So one molarity is 1 molar of stock solution, and another molarity is related to what I have to prepare, that is 0.2 molar. Now one volume I know, that is 200 ml I have to prepare, but how much I should take it from this stock solution I don't know. So what I mean to tell you is, I will take M1 as 1 molar, V1 I don't know how much it is, how much I should take from this stock I don't know. M2 is nothing but 0.2 molar, V2 is nothing but 200 ml. All of you have understood? So now what I will do is, V1 volume of solution of glucose solution, stock solution, I will take and I will make the volume up to 200 ml. So that's where I am going to get the 0.2 molar solution of 200 ml. 0.2 molar solution of 200 ml. All of you have understood? So whatever V1 I am going to get the answer, that will be the volume. Volume of stock solution I should take, and I should make them volume up to 200 ml. Chidwan, we will see how much it will be. Okay. So now we have V1 is equal to 0.2 molar divided by or multiplied by 200 ml divided by 1 molar. So 1 molar will get cancelled. How much it will be? So 0.2 into 200, it will be 40. Fine. So 0.2 into 200. Okay, fine. So that means I should take 40 ml, 40 ml of stock solution, and I should make the volume of 200 ml. You got my point? See, for example, I have a measuring cylinder. All these things you are going to observe in your chemistry laboratory. So this particular measuring cylinder will be having scales on it. Okay, it will be having the scales. So what I will do is, I will take the stock solution of 40 ml. We will imagine this is a 40 ml. I will take the stock solution up to here. Now I will add the water to this. I will add the water to this. How much I should add? So it should come up to 200 ml. It should come up to 200 ml. Okay? So that's where final volume, that will be 200 ml. That is nothing but 0.2 molar of glucose solution. All of you have understood? Here we are not weighing anything. Whatever solution we have, we are taking from that and we are making for the required concentration. Any doubt? Any doubts? So that's where we have got the 40 ml of glucose stock solution. From that I should take 40 ml and I should make up volume up to 200 ml by using the water. Please remember, I am telling making the volume. I am not telling add 200 ml of water. No. If you add 200 ml of water, final volume will become 240 ml. I don't want 240, I want 200. So I should take 40 ml and make the volume up to 200 ml. Fine. Okay, fine. So in that case, shall we solve another one in similar one? Then we will go to the molality, last part. Okay? We will solve another one. These type of things you will come across in your titration. Okay? This year itself, first period, in your practicals. Fine? Okay. So we will move to the next one. Prepare 500 ml of sodium hydroxide of 0.1 molar from 2 molar stock solution. From 2 molar stock solution. Okay? So what is that question? Prepare 500 ml of sodium hydroxide of 0.1 molar. 500 ml of sodium hydroxide of 0.1 molar from 2 molar solution. Can anyone try it out? Okay, what is that final concentration we require? 200 ml. 500 ml. Final concentration volume we require is 500 ml. What is that concentration? 0.1 molar. We require 0.1 molar. Okay, 25 ml. Very good. So answer here is. So what is that stock solution we have? Stock solution we have is 2 molar. So that is 2 molar. What is that required concentration and volume? Required concentration and volume. So that is 500 ml of 0.1 molar. Okay? So that's where, yes, all of you are right. So therefore, by using the formula M1V1 is equal to M2V2. So we have M1 as 2 molar. V1 I don't know. We have to see. M2 is 0.1 molar. And V2 is 500 ml. Right? So therefore, V1 is equal to 0.1 molar multiplied by 500 ml divided by 2 molar. Molar will get cancelled. The final answer will be ml. That means, as the people have written, it will be 25 ml. Right? So what I should do now? I should take the 25 ml of 2 molar glucose solution. I should take 25 ml and I should make up the volume up to 500. I should make up the volume up to 500. I should not add 500 ml. I should make it up to 500 ml. Fine? So that's where we have the calculation. Any doubt in this? If you have any doubts, you can ask. Otherwise, we can move to the next one. We'll move to the next one. Any doubt? Shall we move to the next one? That means last part. Okay, good. So that's where we have the molarity. Try to practice more, and as Manjunath had asked, try to solve in different patterns with related to the same concept. Okay? So we will move to the next one. So next one is related to molality. Very important. This is also very important. That is molality. Molarity is different. Molality, they are different. Only one word, one letter which they differs. That is, in case of the molarity is R-I-T-Y. But here it is L-I-T-Y. Molality. So now, symbol is small m. Okay? So that's where molality, that is small m, is equal to number of moles of solute, divided by mass of solvent in kg. Mass of solvent in kg. Observe it carefully. Please remember, in earlier case it is volume of solution, molarity. It was solution, not solvent. Many students, they will do the mistake. Molarity, they will write the definition molarity as number of moles of solute divided by volume of solvent in liter. That will be wrong. Volume of solution in liter it is. But when it comes to molality, it is number of moles of solute in mass of solvent in kg. Many students, they will write mass of solution in kg. No, it is mass of solvent, not solution. All of you have understood? Try to focus on this particular word. That's where many students, they will do the mistake. So in case of the molarity, it will be written as solution and that will be volume. And in case of molality, it will be mass and related to solvent. Okay? And focus on the last word, kg. In kg, not in grams. So that's where molality is number of moles of solute dissolved in mass of solvent in kg. All of you have understood? You should not forget. Okay? So that's where we have the molality. Symbolically, it will be small m. Capital M is meant for molarity. Capital M is meant for molarity. Here it is small m. Okay? Shall we solve some of the problem related to molality? Any doubts? Now, very important point here is whether volume is dependent on temperature. Can any one of you tell me whether volume is related to temperature or it will have impact on temperature or temperature is having impact on the volume? Can anyone? Whether temperature is going to have effect on the volume? Yes or no? You can just mention. Whether temperature will have effect on the volume? Okay. So, Sanya, it will be having impact. Whenever temperature increases, volume will also increase. Temperature will have the impact on the volume. Yes, many of you are telling yes. Yes, it is directly proportional. Very good. Anyway, these things you are going to study in states of matter, but still, temperature and volume, they are directly related to each other. Very good. Okay. Now, next question. You should tell yes or no. Okay? So, next question. Whether temperature will have any impact. Okay. Yes, sir. Okay. So, next question here is whether temperature will have any effect on mass. Yes or no? Temperature will have any effect on mass? See, Raghavendra sir is weighing 65 kg. I am telling the truth. Yes, all of you are right. See, for example, Raghavendra sir is weighing 65 kg. If I am in Mysore or if I go to America, if I go to Manali, everywhere I should weigh 65 kg. Forget about the height and all. I am talking about the mass. Okay? So mass will remain same. Altitude, yes, weight will have the effect, but mass will remain same. There is no change in the mass. Okay? So water when heated loses mass. No, Rohan, I am not talking heating in such a way that where water molecules will get evaporated. No. Right? We are talking about the condition where there should not be any loss of molecules. Got my point? So during that time, if I take a water, whether I have 20 degrees Celsius or whether I have 30 degrees Celsius, mass will not be having any change. Mass will remain same until unless we provide such a high temperature that some of the molecule will escape. We are not talking about escaping of molecules. Got my point? So therefore, mass will not effect of the temperature. So therefore, listen to me carefully. So therefore, molarity depends on the temperature. Molality is independent of temperature. What my point? So that means molarity will have impact of temperature because divided by volume of solution. So therefore they will have the effect of temperature. Molality will not have the effect because divided by mass of the solvent. Got my point? So therefore molality depends on the temperature. Molality is independent of temperature. All of you have understood? Any doubt in this statement? Why molarity depends on the temperature? Because in its equation itself it is there. Volume of solution. Got my point? But when it comes to molality, why it is independent of temperature? Because in the formula itself it is there. It is divided by mass of the solvent. Numerator is common in both the case. That is number of moles of solute. Okay? So we will solve some problems. Okay now? Okay, done. So next, you can write it down. Density of, see, we have discussed about density, right? And I told you people that these information might be required to solve some of the problems. See here. So density of 2 molar solution of NaCl, that is sodium chloride, is 1.1 grams per ml. 1.1 grams per ml. Calculate the molality. Calculate the molality of the above solution. Molality of the above solution. Got my point? So density of 2 molar solution of NaCl is 1.1 gram per ml. Calculate the molality of the above solution. What is that data they have given? They have just mentioned the density and they have asked us to calculate the molality. How to do? First thing, since they have asked about molality, we should know the definition or equation. Small m I have written. Small m is equal to number of moles of solute. Which is the solute here? In this problem, solute is NaCl, right? Divided by mass of solvent in kg. Okay, mass of solvent in kg. Can any one of you can tell me? Okay, Yagnesh, that is related to density. Yes, mass by volume. So therefore 1.1 gram divided by 1 ml. That is mass by volume. Now this is related to molality, this equation. Okay. Now whether numerator we know. Numerator, that is number of moles of solute of NaCl, whether we know. If we know how much it is, what is that value? Can any one of you? What is the numerator? What is the number of moles of solute? Whether we know that one or we have to calculate? Yes or no? Okay, Yagnesh, we don't know. We don't know what is the number of moles of NaCl. All of you will agree? What? Yagnesh, removed. No, if it is wrong or right, anything is fine. So whether we know number of moles, okay, we have to calculate. We should calculate. Okay, all of you will agree with that? Yagnesh, we should not calculate. No means we should not calculate. Yes. We have one dialogue, right? No means no. Yes. We cannot calculate. No requirement of calculation. All of you, no requirement of calculation of number of moles. Already it is given here. 2 molar solution. 2 molar solution means what? 2 moles of solute. 2 molar solution means 2 moles of solute divided by 1 liter of solution. So already number of moles they have given. So therefore, number of moles of NaCl is 2 moles. 2 moles. Already it is given. Don't get confused. Read the question. You can read the question twice. Okay. So already it is given 2 molar solution. So therefore, number of moles it is given 2 moles. So numerator, no problem. But denominator, there is an issue. Because they have given the density of the solution. That is 1.1 gram per ml. Density of solution. Solution means what? Solution means solute plus solvent. Solution is nothing but solute plus solvent. But we require mass of solvent only. We don't want mass of solution. We require mass of solvent. So therefore, how to calculate the mass of solvent? Mass of solvent will be equal to, observe carefully, mass of solvent will be equal to mass of solution minus mass of solute. Mass of solution minus mass of solute. All of you will agree? That's where we can calculate the mass of solvent. They have not given mass of solvent. We have to find it out. Okay? So for that we should find out first what is the total mass of solution minus what is that mass of solute what we have. Got my point? All of you have understood? Any doubt? In these two statements, any doubt? Okay, fine. So in that case, if you don't have any doubt, now can any one of you, just tell me yes or no. Can any one of you, okay, Yagnesh, you have not understood? Okay, so what I mean to tell you is, molarity is nothing but number of moles of solute divided by mass of solvent. I will explain it. So molality is nothing but number of moles of solute, that is, in this case it is NaCl, divided by mass of solvent in kg. All of you will agree? So this is the equation. And we have to calculate the molality. That's why I am writing molality equation. Now, whether we should know the numerator, that is number of moles of solute, that is NaCl. Whether we know? Yes, we know that one. Okay? Anyway, fine, Yagnesh, I will explain it once again. So that is number of moles of NaCl is 2 moles. That is because we have 2 molar solution. So 2 molar solution is nothing but 2 moles of solute, that is NaCl, in 1 liter of solvent. That's where we have the 2 molar. Okay? So 2 moles. Now, denominator, what is that? Mass of solvent. So how to find the mass of solvent? So to find out the mass of solvent, first we should know what is the total mass of solution. What is solution? Solvent plus solute. Together it will become solution. So therefore, if I find out the mass of solution, if I minus with the mass of solute, then I am going to get the mass of solvent. So now I have to make 2 calculations. One for mass of solution, I have to find out what is the mass of solution. Next one, I have to find out what is the mass of solute. All of you have understood? I have to do 2 calculations. Fine. First I will do mass of solution. How to find the mass of solution? By given information, that is density. Right? Since density of given solution is 1.1 gram divided by 1 ml. So what do you mean by that? That means if I take 1 ml of this solution, that is 2 molar NaCl solution, if I take 1 ml, it will weigh 1.1 gram. That's where the density talks about. Mass by volume. Right? So that's where I have the, yes Agnesh, mass by volume. That means if I take 1 ml of this particular solution, it will weigh 1.1 gram. That solution mass will be 1.1 gram. So in that case, what is that total mass? What is that total mass? That is 1000 ml. What will be the total mass of the solution? That is 1000 ml of solution. Right? So therefore, for 1 ml, it will weigh 1.1 gram. How much for 1000 ml? That is nothing but 1 liter. ml will get cancelled. What is the answer? 1100 grams. 1100 grams. So 1100 gram is the mass of solution. We have got mass of solution is the mass of solution. If you are not understanding, let me know. It is the mass of solution. One step is done. We have got the mass of solution. Now what we have to do? We have to find the mass of solute. We have to find the mass of solute. How to find the mass of solute? Can any one of you? How to find the mass of solute? So mass of solute is equal to, since 2 molar solution, since the given solution is 2 molar, that means we have 2 moles of NaCl. That means we have 2 moles of NaCl. So 1 mole of NaCl is going to weigh its molar mass. 1 mole of NaCl is going to weigh to its molar mass. That is, molar mass of NaCl is 23 plus 35.5, that is nothing but 58.5 grams. So that is the molar mass of NaCl. 58.5 gram is the molar mass of NaCl. So if I take 58.5 grams of NaCl, it indicates I have got 1 mole of NaCl. Chidwan, absolutely correct. If I take 58.5 grams of NaCl, that corresponds to 1 mole. For 2 mole, it corresponds to how much mass? What my point? So for 58.5 grams of NaCl, it is nothing but 1 mole. For 2 moles, sorry, I would have written reverse. For 1 mole, it is 58.5 grams. How much for 2 moles? How much it will be? 117 grams. As you people have written, it is 117 grams of NaCl. That is solute. That is solute. 144. What is that, Yagnesh? 144. It should be 117. 2 into 58.5. So mole and mole will get cancelled. All of you have understood? Because I have to remove this, because I have to write a new one next step. But all of you have understood. So what we have done is, in the given question, it is that 2 molar NaCl solution they have told. 2 molar NaCl solution. Then they have given the density of that NaCl as 1.1 gram per ml. So what it indicates, that means if I take 1 ml of 2 molar NaCl solution, it will weigh 1.1 gram. That's what that density indicates. So they have asked us to calculate the molality. So therefore, first thing we have to write the equation for molality. Molality is equal to number of moles of solute, in this case NaCl, divided by mass of solvent in kg. Okay. Now, number of moles of NaCl already they have given by mentioning that it is a 2 molar solution. That means we have 2 moles of NaCl. In the denominator, we have mass of solvent in kg. That means mass of solvent we have to calculate. They have not given. So to calculate the mass of solvent, we should know what is the mass of solution minus mass of solute. If you minus, then only we are going to get the mass of solvent, because solution is nothing but solvent plus solute. So if I take out this mass of solute, leftover will be mass of solvent. So that's where I have the equation. Okay. Now, mass of solution can be identified by using the density, which does that 1 ml it will weigh 1.1 gram. If I take 1000 ml, how much is going to weigh? So it will be 1100 gram. 1100 gram. Okay, that is the mass of solution. Next, I have to find out mass of solute, because mass of solution I have got it as 1100. Now I have to find out mass of solute. So to find out the mass of solute, I have to use the information this one. That is 2 molar solution. All of us we know molar mass of NaCl is 58.5 grams. So therefore, for 1 mole it will be 58.5 gram. For 2 mole, how much it will be? For 2 moles, how much it will be? Yes, Sanya, very good. So that's where I have got the 117 gram as the mass of solute. All of you have understood? Shall I move to the next step? That is, I am going to find out mass of solvent. I am going to find the mass of solvent. Okay. So just these values, substitute these values here. So mass of solvent is equal to 100 gram, that is mass of solution, minus 117 gram of mass of solute. So the final mass of solvent will be 983 grams. 983 grams. So whether it is done? No. We have got the mass of solvent. Still we have to find the molality. So therefore, small m, molality is equal to number of moles of solute. How much it is? That is 2. 2 moles divided by, what is the mass of solvent in kg? That's where it is important. What is the mass of solvent in kg? Yes, absolutely correct. Final answer. Andani. It will be 2.03. Very good. So, mass of solvent in kg. What to do? Yes, Sanya. Absolutely right. So, therefore, whatever we have got, that is 983 gram. Convert that one into kg. Because we know that 1000 gram is equal to 1 kg. 1000 gram is equal to 1 kg. So therefore 983 gram will be equal to 0.983 kg. Some students, they will directly write it as 983. No, it will be 0.983 kg. So therefore final answer will be 2.03 molality, or you can simply mention it as 2.03 small m, or you can mention it as 2.03 moles per kg of solvent. 2.03 moles per kg of solvent. Got my point? So that's where we have the molality. All of you have understood? So that's where we have the molarity calculation. Normally, if it is asked, it will be for 4 marks, not less than that. So many steps are there. For your competitive exams, it will be help you out. Okay? We will solve another one, last one. Okay? So in this case, they had given density and they had asked us to find out the molality. And even they had given what is the molarity. Okay? So we have used those two things, density and molarity. By using that, we have calculated what is molality. Okay? Last one. Okay? Calculate the molality. Calculate the molality of glucose solution. Calculate the molarity of glucose solution when 80 grams of 80 grams of glucose added to water of 1 liter. Water of 1 liter. Okay, so can you find out what is the molality of glucose solution when 80 gram of glucose is added to water of 1 liter? It's actually straight calculation. Any one of you? Last 2 minutes. Any one of you? It's easy calculation. Observe the problem carefully. Read that problem carefully. you can solve. Okay, now we know whoever is solving, you start solving that one. Sir, first we should calculate moles. Yes, of course, very good. We have to calculate the number of moles. So, molality is equal to, this is small m, number of moles of solute divided by mass of solvent in kg. That is the definition. Number of moles we don't know. We have to calculate. It is very easy. So that is nothing but given mass divided by molar mass. What is that given mass? 80 gram. What is that molar mass of glucose? That is nothing but 180 gram. C6H12O6, right? So molar mass of glucose will be 180 gram. So given mass divided by molar mass, it will give the number of moles of glucose. Now mass of solvent in kg. So density of water, we should use the information. Density of water is 1 gram per 1 ml. Density of water is 1 gram per ml. That means 1 liter means, yes, all of you are right. So 1 liter means 1000 ml. 1000 ml means 1000 gram. That means 1 kg. So therefore 1 liter, that is nothing but 1000 ml. It will be 1000 grams per 1000 ml. 1000 grams per 1000 ml. That's where we have the water, 1 liter. It will weigh just 1 kg. Right? So therefore I will write it as 1 kg. That is nothing but 80 divided by 180 is nothing but 0.44 moles divided by 1 kg. So that is nothing but 0.44 molarity or 0.44 moles per kg of solvent. All of you have understood? So that's how we can solve these problems. Okay, fine. So anyway, I will stop here. Any doubts related to this? Any doubts? Since they have mentioned it as water and volume they have given as 1 liter, straight away we can take it as 1000 gram because density of water is grams per ml. 1 gram per 1 ml. So 1 liter means 1000 ml. It corresponds to 1 kg. That is 1000 grams. Any doubts? Okay. So the final answer will be 0.44 molality. Yes, we have to mention the unit. Very good. Okay, fine. So in that case, from tomorrow we are going to start with the new topic, that is atomic structure, which is also very important for your examination point of view. Very large topic also, very important. Okay. So by this we have done with basic concepts of chemistry. So try to solve more problems from the check sheet and from the textbook. Okay. So related to first topic. So tomorrow we are going to start with structure of atom. Fine. Thank you. Take care. Thank you.